Introduction to slope. Now, no, this is not our first introduction to slope. You've seen slope in 6-7. We've also touched on pieces of slope as we've worked through the year. This is our real, hey, we are ready to get into functions. We're about to roll right into equations. It's time you really know slope. So we're going to talk about it a little bit more exhaustively today. What is slope? Now, you see the individual skiing on the screen. Slope is the steepness of a line. Now, we talk about slope in relation to straight lines. Most of the straight lines you dealt with last year went through the origin because they had direct variation. But this year, we're going to deviate away from straight lines that go through the origin. You'll see what we mean as we get into them later this year. Types of slope. Now, we've already seen types of slope as we talked about the characteristics of functions, because you add increasing, decreasing, and constant. So you're going to see some overlap here. This appears to be increasing. Well, when it's increasing, we call it positive slope. This appears to be decreasing. When it's decreasing, we call it negative slope. Yes, this appears to be constant, and it certainly is. We can call it constant, but typically we're going to call it zero or no slope. And then last but not least, this is not a function. Remember, it's a vertical line, so it fails the vertical line test itself. But it's important for us to understand that any vertical line is undefined. It is not a function. Slope is sometimes referred to as the rate of change between 2 points, and quite often you will be given 2 points and asked to find the slope. The letter M is now going to be used to represent the slope. Now, remember that last year you were finding the constant of proportion, so you had y equals kx as your format for the equation. And this year we're going to be substituting M for k. And so M is going to be the letter representing slope. Now, if you're given 2 points of a line, you can find slope using the formula M is equal to y2 minus y1 over x2 minus x1. And the way we've been talking about this a lot so far with functions is the change in the y's, in other words, the difference in y's, over the change in the x's. And that's important language for us to be familiar with when it comes to math and slope. y2 minus y1 over x2 minus x1. So now I'm just going to give us some ordered pairs so we can try this formula. So M is equal to y2 minus y1 over x2 minus x1. And one of the things I tend to do is label an ordered pair. So I have my first ordered pair, my second ordered pair. I have an x, I have a y, I have an x, I have a y. This helps me keep track of what parts I'm putting into the equation. Now, next thing that's important, we see a y sub 2. That is not the same thing as y squared. We're not thinking like we were in Pythagorean theorem where I have a y with a 2 and I have to square it. Rather, sub 2 means from my second data point or my second piece of information. You're going to see subs come into play a lot more next year. And so it's just important for you to recognize that a sub, or a value that's subscripted next to a term, is used to identify or label a term. So let's fill in what we know. M is equal to y2. I want the y value from my second ordered pair. So that would be 19 minus y1. I want the y value from my first ordered pair. Over x2, so my x value from my second ordered pair, over x1, my x value from my first ordered pair. Now, it is very important that you're keeping these in the correct order. While it doesn't matter which one of these is 1 and which one of these is 2, it does matter that once you've labeled them, you treat that one as 1, you treat that one as 2. So now we just simplify. 19 minus 7 is equal to 12. 5 minus 3, well, that's equal to 2. So we can simplify that further. 12 over 2 is 6. So we have an m value that's equal to 6. That wasn't too bad. Go ahead and pause the video, see if you can solve this one. Be very careful with those negatives. All right, first thing you should have done is written down the slope formula. M is equal to y2 minus y1 over x2 minus x1. We're going to substitute in. So I'm going to label an ordered pair 1 and an ordered pair 2. X, Y, X, Y. I know it's a pain to label things, but that took like what? Literally a second and a half. So y2, my second ordered pair, y value is negative 2 minus my y value from my first ordered pair over my x value from my second ordered pair, so negative 6 minus my x value from my first ordered pair. So let's simplify. Negative 2 minus 4 is negative 6. Negative 6 minus 3 is negative 9. Now I have a negative over a negative, so those are going to simplify each other and make themselves positive. 6 over 9, both are divisible by 3, so it can simplify down to 2/3. So my m value is equal to 2/3. Now, if we're given a graph, and graphs are super helpful, and you've seen me do this a little bit when we were looking at some of the characteristics of functions, a little bit when we were looking at the comparative functions and graphs versus tables versus verbal statements versus relations, is slope can be found using rise over run. Well, what does that mean? That means that if I'm given a graph, we can determine the rise. We can determine the rise. So I'm going to make a triangle out of the two ordered pairs that I see intersect perfectly with the grid lines. Now, no, I'm not making a triangle for Pythagorean theorem, but you could see some similarities in that we did the same thing when we were doing Pythagorean theorem. We made a triangle out of a diagonal line, and you were able to count up to figure out one side, count across to figure the other. Well, we're going to do the same thing here. Up 1, up 2, up 3, up 4 units. So we've gone up 4. Across 1, 2, 3, 4, 5 units. Now remember the previous slide said that slope, my m value, is equal to rise over run. So that's going to be equal to, we rose 4, we ran 5. So m is equal to 4/5. Now I like rise over run because it's very quick to identify the slope. It just requires you to have a graph. All right, see if you can give this one a shot. All right. Notice we have a line going down. So the very first thing I know is that my slope is negative. So let's see how much. I'm going to go down 1, negative 1, over 3. So I have a negative 1 over 3. That's my slope. M is equal to negative 1/3. Slope-intercept form. Now, I have been hinting for the past couple weeks that we are going to deviate away from your constant of proportion equation, y equals kx, and we're going to start to modify it. Here's what we're modifying. First of all, we're replacing m. So m is now your slope instead of k being your slope. They are still relating to constant rate of change, but when we have k, we're talking about an equation with direct variation. In other words, there's no b value. When we do not have k, in other words, we have a b value, we shift over to m being our slope. And really from this point on, while it's important for us to see the significance in direct variation, you're never going to use k as a value of slope. So just get m stuck in your head and keep moving forward with m. So find the slope of the line. Now, we should see that this is in y equals mx plus b notation, where the m value here is the slope. So m is equal to -4. This one doesn't look the same. What's different about it? X and y are on the same side of the equation. Well, it's possible to move x and y to separate sides of the equation, and since my y value has a negative coefficient in front of it, I'm going to go ahead and make it positive by adding 3y to both sides. So 2x is equal to 3y plus 6. Now we'll move the 6 away by subtracting 6 from both sides. 2x minus 6 is equal to 3y. And we still want to get y all by itself by dividing. Now, it's been a while since you guys have divided fractions this way, but we can divide both sides by 3, and this is going to simplify out, and y is going to be equal to, but let's simplify this a little bit, because I really want to know what the slope is. Anytime you have an expression in the numerator, you can separate that expression as long as you put a common denominator underneath each term. So 2x over 3 minus 6 over 3, which we can clean up a little bit. Y is equal to 2/3 x minus 2. Now we're finally in our y equals mx plus b notation, where I can see that the value in front of x, when we're in slope-intercept form, is a m value of 2/3.